the challenges with that is as the web get popular, well, a lot of people would want that page, and they all click on it, and you get congestion at the data center. And I remember back in 1995 at MIT, Tim Berners-Lee was down the hall. And he came over to our group. We were doing theoretical computer science, large-scale networks, distributed computing kinds of things. And he said, hey, I'm worried about the congestion problem on the web as the web gets popular. This is pretty good because it's not 1995. Most people weren't using the web back then. And that was a great problem for our team to work on. This first became famous as a problem. Let's turn the mic on. All right, remind me how I do that. Help me out. All right, is that, oh.
Are you sure you want the mic on? The first time this became well known was after the 1999 Super Bowl. And in the Victoria's Secret was one of the first, maybe we don't want this because it's going to do that. Yeah, I think technology is struggling today. We're on a different laptop, so some of the slides will be interesting. When you go, from PC to Mac, PowerPoint can do interesting things. Yeah, why don't we just not use this? I have a good voice still. Okay, that okay? All right, we'll give that a try. Anyway, Victoria's Secret, interestingly enough, was one of the very first e-commerce sites. And so they wanted to sell lingerie online, and that's before anybody was selling really anything online. And to let people know that you could buy your lingerie online, they ran an ad in the '99 Super Bowl. And of course, that's where you get the really cool ads. The ad showed models in lingerie walking down the runway. And, and you got 100 million people had a little beer watching the Super Bowl. And it said, if you want to see the full fashion show, come to our website, www.victoriassecret.com, Tuesday night at 9 o'clock, and you could see the whole fashion show for free. Okay, so Tuesday night, a little before 9 o'clock, they don't know how many people went because they had provisioned the site for about 300 megabits a second, and that's not very much. And presumably millions of people went, and not only did it crash Victoria's Secret, it crashed the internet in Texas, was taken offline. So nobody saw the fashion show, but it made great headlines. The next day, Wednesday morning, all the major newspapers, in the US ran headlines, Victoria's Secret crashes the internet. So they viewed it as a huge success because everybody knew that then Victoria's Secret was on the internet. No, it wasn't the original intention, but this is exactly the problem that Tim was worried about. That if a lot of people go to a website, and this was hosted in Dallas, I think it was on broadcast.com way back in the day, that you couldn't possibly keep up with the demand. Because the way the web still works today is that anybody who wants to watch a video, you got to give them their own stream. There's no, multicast has been around 40 years at least, but it's not how the internet works. You give a unicast stream to everybody even today, and if one location is trying to dish out these streams, it just gets congested, overwhelmed, and nobody gets it. You just collapse. So then it became, a famous problem. And this is around the time that we started with Akamai. Tim presented this challenge to us in '95. We worked on it as an academic project at MIT for several years. And the idea behind what we wanted to do was to use distributed computing to deliver content. For example, streams of the fashion show. And the idea was to place servers that could, deliver content in thousands of locations. Anywhere there were end users, get near the end users in their city, in their neighborhood, in their network. And by that way, everybody could watch the stream. Because they're not all going to one place, they're just going to their local server that we placed there. So a pretty simple idea. to make it work, there's a lot of complication, a lot of mathematics and algorithms, because it's not just the Victoria's Secret stream, it's a lot of the content on the web, and you got to direct people to the right server that has the content they want in real time without overloading any servers. So a lot of interesting mathematics and algorithms to make it work. Now sometimes the content you want might be personal. Maybe it's your bank account balance, your medical records. And there you don't want to have that stored and cached. You certainly don't want to give it to anybody else. And so we do have to have a mechanism from the server that's near the user to go back to the core data center where maybe it's locked in a vault, your personal information. And we need to do that in a reliable way. And the internet, as a whole is pretty reliable, but at any given time things are broken. Things get congested in the internet, so you have to find paths around it. So you can get access to your bank account quickly, even if the normal internet path is congested. So we built protocols to do that. We built a virtual internet on top of the real internet. We live with BGP, or the Border Gateway Protocol, underneath. We built our own version of these things on top so we can have reliable point-to-point connectivity, even if the internet wouldn't give us that. Now, over time, traffic has grown a lot on the internet. I remember we were pretty excited 10 years ago when we were delivering a terabit of content per second. Seemed like a really big deal. And just to put that in context, that's what you would need to deliver a video encoded at 1 megabit per second to 1 million people simultaneously. Now, a megabit per second is not as good as standard def TV. The old standard def TV is 2 to 3 megabits per second to deliver in a compressed format that looks like standard def TV. So less than that. And of course, 10 years ago, that's sort of what you would see on the internet. And then last month, we were up to 72 terabits per second. And just to put that into context, that's enough for 18 million people to watch a video encoded at 4 megabits per second. Now, 4 megabits per second is low-end DVD, not HD, DVR, just DVD, the old thing you bought and stuck in, not Blu-ray. That's about 4 to 5 meg, and that's only 18 million viewers at one time. Now, today, when you watch video on the internet, 4 megabits per second is about the average. Nobody's doing 1 meg anymore. If you're watching movies, they're trying to get you 10 meg today. So you look at this, you say, wow, that's only 18 million people at so-so quality. Where is this headed? Where are we going on the internet? And there's 3 big distributors of video today. There's us, there's YouTube, and there's Netflix globally. And ballpark, within a factor of 2, all the same size, that looks pretty small. Well, I can imagine a world with 2.5 billion people watching a movie or TV during prime time. Already, over 2.5 billion people have watched a video on the internet. But imagine they're doing it every night. You go home, you watch TV or a movie, and suppose they're doing it at a quality level of 10 megs. That is what the folks doing movies are striving for today. It's not 4K. 4K compressed, but it still has a good picture, that's 16 meg. When we do the Olympics in 2020, that's going to be broadcast in 8K. And that's not AR or VR, much more bandwidth. So 10 meg is conservative. But you all can do the math. 2.5 billion people at 10 megs is 25,000 terabits a second. And today it's a big deal doing 72. Put us together with the other big guys, a few hundred today. That's a whopper. This is a huge challenge to get there. Just the power needed to drive this is a big deal. And so now a lot of people think that the barrier to getting there is the last mile or the connection into your homes, and that's not true anymore. 20 years ago, we got started. I don't know what the modems were doing then, 256K or something. That was the last mile was a challenge. Now you all have big broadband into your homes, into the school. There's in Paris today, typical home has a gigabit down into the home, 250 megs out of the home. You go to Singapore, Seoul, any of these cities, the average is a gigabit into your homes now. In this country, probably it's certainly tens of megabits per second. Many have 100 megabit per second. But if you do the math on this, if you look at the edge of the internet, connections into homes and offices and schools, I'm sure this is wrong by a factor of 2 here and there, but ballpark close to 1 billion connections and an average of 40 megabits a second. All right, so you've got plenty of capacity in the last mile for billions of people to watch a decent quality video at the same time. Now, this is not true in some countries that have, India, for example, today, probably there's at least tens of millions, maybe 100 million people that have good connectivity. There's another billion plus that don't. And of them, there's 400 million that have a device, but it's cellular, and you don't have good bandwidth there. But in the major cities around the world, in the fully internet developed world, you have a ton of capacity in the last mile. The problem in the internet today is in the core, what people call the cloud. You got the Amazon data centers, you got the big enterprise data centers, you got the big backbones. And if you look at the capacity there, today, if we measure it by the backbones, there's only really worldwide 2 to 3 dozen major carriers, but say we round up and say there's 100 major tier 1 providers, and their backbone capacity is nowhere near 5 terabits a second if you cut the backbone. Much smaller than that, but say you give credit for growth, this can scale to hundreds of terabits per second. And that is nowhere near enough. All right, you've got a huge imbalance between what's at the edge and the demand there, where the people are, and what you can deliver out of the core. And that creates a problem that we already see today. People trying to go to the core to get it, and you get congestion. And it's not the data centers that usually fall over today. It's the peering points. It's the connection points between the carriers and the network providers near the data center. And that's what gets swamped out. And that causes problems with performance. And so this is why 20 years ago, going back to Tim's original thesis, is you need to be delivering this from the edge. If you try to go get your stream from the relatively small number of core data centers, they're going to get swamped just like Victoria's Secret did. In this country today, we had the big fight over net neutrality. The real genesis of that was a battle between Netflix and the big carriers, because Netflix is trying to send the videos to you at your home through the big backbones, AT&T's backbone. It gets swamped at the peering points, all right? And so they can't get 10 megs to a lot of your homes. And so they said, hey, AT&T needs to upgrade this and build a lot more capacity so we can reach you. And by the way, AT&T should pay for it. Well, AT&T's not so excited about paying when they don't get anything for it, for Netflix to come in. And so that led to the net neutrality fight, and today the rules have all been revoked, but you get a new administration, could go back the other way, hard to know. It's a business fight. At the end of the day, even if AT&T wanted to, they couldn't begin to afford to build out all this core capacity because it just doesn't make sense to deliver these videos from the core. You've got to deliver them from the neighborhood. And in fact, long run, and I've been wrong in the prediction as to when this would be required. I thought it would have been required by now. You got to deliver the videos from your neighbor's home, or at least 99% of the bits in the long run. You got to take advantage of the power that's in the neighbor's home, the colo that's there, and the equipment, the router they've got there, the cable modem. And that's, I think, in the long run, the only way effectively to get to tens of thousands of terabits per second. You just can't afford, to do it in the internet. So we've built all the software. We're deployed in over 100 million homes today. It's not widely used. We don't call it peer-to-peer because the content companies and the carriers break out in hives if you say peer-to-peer because of all the theft way back when. We call it client-assisted delivery. And it still hasn't caught on. Someday it has to, just from the technical perspective. Today, we've been in business now 20 years. We've got about 250,000 servers deployed. And the important part is not how many there are, but how many locations they're in. They're in 4,000 locations around the world in 133 countries. We're inside the 1,700 biggest networks that make up the internet. We're delivering a lot of content. Most of the content, take out Netflix and YouTube, most of the content you get on the internet comes from us. Any shopping site you go to, really what's happening when you click is your device is coming to our server near you. You're not getting to the website. And we process all that transaction on behalf of the commerce sites. Any bank you go to in this country, that comes to us. And we make it be a fast experience for you. And the banks and the commerce companies and the media companies pay us to do that. And so we do business with pretty much all the major websites here and around the world today. All top 25 banks, all the major commerce sites, and much of the media sites. So you're using us every day, but you don't know it. We joke with our marketing department, we're the biggest entity on the internet you've never heard of, which is not our strategy. We want to be better known, but we're sort of like plumbing, underneath the covers. Now, I'm going to shift gears a little bit and mostly talk today about security. Nobody knows we do security, but we're the world's largest security provider, pure play cloud security provider today. This is an enormous problem, and we need talent like you have to really figure this out. It's just, nothing is safe. Every time you think you've seen the most egregious data breach or attack, well, then you get the next one, you go, oh my God, how did this happen? And you look at the name brands of the companies that have been affected and you go, were they just not paying attention? Were they lazy? Were they stupid? The chief security officer, the chief information officer, and no, they're smart people at these companies. These companies are spending a lot of money. It's just a hard problem. It's so much harder to defend than it is to attack. In fact, you look at the source of the attacks. In the old days, there was the prototypical, teenage hacker in the garage impressing their friends. That is not the problem. Today, you've got political hacktivism, groups like Anonymous. There's millions of followers of these groups. Otherwise, law-abiding citizens that unwittingly or even wittingly participate in attacks and think it's okay. You got state-sponsored attacks, and you got the world's biggest countries doing this, and they've got a lot of talent, a lot of money. They are highly motivated, to run cyber exploits. And you got organized crime, and they have figured out there's a ton of money in stealing your identity, stealing your medical histories, taking over your bank account, other accounts you have. This is a huge business today. And so the attackers are really powerful, and they're aided by, it's just so easy to do. I think the best example of just how easy it is the Heartbleed incident. How many of you know about that from, all right, so a few of you, but that's just I think the most stunning of all. Everybody uses something called OpenSSL to secure transactions. Any time you go on the web, it's secured, but it's secured with OpenSSL. And the idea being it's open source, so it's so much more secure. And so at one point in OpenSSL, they made a little patch just for a liveness check. And it was ubiquitous for 3.5 years without anybody in the public world knowing that it was easily exploitable to get your secret key. And of course, if you get the secret key, you can listen into everything you do. Everything was exposed on the internet for 3.5 years. And, just in fact, the most amazing thing, the liveness check was you send a query to see if the server's live, and you send it, I think it was 64 bytes, and then does the server give you back the same 64 bytes? Well, the way it got coded was that the server was only provisioning 16 kilobytes, but it had to return 64. And so it returned the 16 of your first 16, but then 48 more that just happened to be there. And what do you suppose was in the next 48 kilobytes as often as not? The secret key, because it's right there for it. It was that simple. In fact, once the vulnerability became known, we were thinking, Jesus, organized crime must have known this. Any intelligence agency worth their salt must have known this. So we asked some of our developers, without telling them what the vulnerability was, we told them there is a vulnerability in OpenSSL, and you can expose your keys. Figure it out. Half an hour. They figured it out. But for 3.5 years, nobody's thinking that, hey, there's a vulnerability, because we just assume open source is secure because everybody's looked at it. Not so good. Phishing, everybody's vulnerable. I don't care how many trainings you go through, and in the corporate world, this is a big deal. I click on the wrong link and all hell breaks loose, because then they own me. This is an example of one that's pretty good. They know I go by Tom, which is my middle name. All right, they don't go by my first name, which is Frank. Of course, they know that any executive every employee in a company today has to go through security training. And they know our chief security officers, Andy Ellis, and they know he's going to send me reminders to do my security training. And now this is, actually, you look at that, it's training.akamai.com. But, my eyes aren't great. That looks like akamai.com. Click, disaster. They own me. Once I click, done. And everybody's going to get hit with this. We actually now own this domain. Now, making this even worse is IoT. There's billions and billions of devices out there now that they got a strong, fully powerful CPU, full communication stack, and they have access to all that bandwidth going into the homes and the offices. Huge resources, and they have absolutely no security. If they have a password, it's the industry preset password, 1234, or something like that. Most of them, you can't change the password if they have one. Zero security. So you've got billions of devices that are just trivial to take over, and when you take them over, you can use them to launch attacks, create massive botnets. You can go on the black market and buy and sell huge bot armies to do whatever you want. That's a huge problem. And it's not computers. These are video cameras, air conditioning units, refrigerators. Everything has, chips in it these days and is connected. And now you think about this capacity imbalance. You got tens of thousands of terabits a second of capacity into the homes where these devices are, and the big companies have their applications and data stored in a relatively small number of cloud data centers in the core. So what happens is they make these botnets and launch these attacks against a target overwhelmed. It's even worse than Victoria's Secret because it can be done, on command. And that's a big problem. Now, today, like last year, we defended sites with attacks of well over a terabit per second. And you talk to security people or a company and you say there was an attack of a terabit per second, they go, oh my God, that's enormous. Because you can't provision that themselves. They can't even afford it. Even if they could, you couldn't do it. And what people don't realize is that's the tip of the iceberg. You can go far bigger than that. And the curve of the size of the attacks is ramping up rapidly, just to put this in context, with somewhere between 1 and 2 terabits a second, if you direct it against Australia, you can disconnect Australia from the rest of the world. You know, most European countries, a few terabits per second, launched in the right way, disconnect that country from the rest of the world. Now, not the US. The US has much more than that. But most countries today, we're already at the threshold where you can disconnect countries. No enterprise can withstand this. Now, here's where the infrastructure we built to deliver video at scale and to deliver content can actually help. Because those same servers we have out there at the edge where all the capacity is, we put in defensive security software. And so we absorb the attacks and filter out the attacks at the edge. Now, if it's a distributed attack, we just absorb it because there's all this capacity. And if they vector in the attack, they can take out Akamai servers. As I speak now, probably hundreds of Akamai servers have been swamped with attack traffic. But there's, you know, hundreds of thousands more. And we redirect traffic on the fly so nobody knows the site, somebody's trying to DOS the site. Now, the next challenge is with the bots. And people don't realize it today, but most of the traffic on the internet is already not human. It's bots. And the next thing about bots is it's not just a good, bad situation. There are all sorts of bots. You know, and some of them are good. The Google bots. You want the Google bot to get a really fast response with the right keywords, so you get a good search ranking. And people pay a lot of money to companies to figure out how to do that. You know, you've got, your partners often have bots as a company. You've got the sort of the bad bots are scraper bots. Like if you run a commerce site and you're selling stuff, there's some aggregators that you want their bots to see what you're selling and the price because they're going to help you get traffic. Because a lot of you may go to a site, well, buying tickets online, that aggregates and finds the best price for you. And so you go to the aggregation site. Now, you ever go to one of those sites to buy something and you see that, you know, one company is selling it for $10, another company is selling it for $9.99, and of course the $9.99 appears first, and you tend to click on the top one because that's the cheapest. Well, what's happened is the company that's at $9.99 has scraped the site of the company at $10, automatically taken a penny off everything, and posted that, and then that goes into the aggregator. And so for running a commerce site, a large fraction of the traffic, sometimes the majority, is their competitors scraping their site. All right, and they don't want the competitors to be able to do that. They really like to trick the competitors and put the wrong pricing in. So they list a higher price. And then you've got the hacker bots they're the worst. They're taking over your bank account. Now, if you're like everybody else in the world, you've got logins on dozens of sites. You can't possibly remember dozens of passwords. So you use the same on many sites. Invariably, some of those sites get breached. Your password gets taken by a criminal entity that then hires a botnet to try your credentials on 5,000 big sites. Okay? And then when the botnet gets in and finds a match that, yeah, you had an account on that other site and you used the same password, they then sell it to organized crime to exploit it. All right? And so today, the vast majority of logins on sites is this. Not real users, but these botnets trying out stolen credentials. And for sure there you want to, actually you don't want to block them, you want to tell them that that credential that they stole, which is valid, you want to tell them it's invalid because they're used to that and then they ditch it. And then you want to go fix the account and tell the account holder, hey, your account information got stolen. And so really what you want to do in today's internet world is know what type of bot is coming and make your response be appropriate for that bot. So Google gets fast service, the right keywords. You know, your competitor who's scraping your prices, you want to give them false prices. So instead of showing them $10, you want to tell them $20 and now they list at $19.99, right? And so all this response you want to have happen on the fly, but that means you got to know what entity is coming to your site. So it's not just one site for everybody anymore. And this is our fastest growing product ever, is that we call Bot Manager that does this. You know, it tells the type of bot. It knows, is it a human? It knows, is it you logging into your bank account, or is it a bot logging into your bank account with your credentials? And then responds accordingly. And there is some chance I can actually show you how it works. We're using some very cool technology here with machine learning. You know, what we've done is amass zillions of real human user profiles logging in to your bank account. Pretty much, I'm guessing all of you, when you log into your bank account, really you're doing that through us. And we're keeping track of how you move your mouse, how you click on your device, how you hold your device. When you tap, does your device move? And we create from that the human profile. And we're also keeping track of the bots so that in real time we can tell, is it a human or a bot? And so let me show you how that works and what we're doing under the covers that you don't see, but probably you all are experiencing this. Let's see if this is going to work. So far, so good. What I'm going to do here is tether my device here to the laptop with luck. Let's see if the Wi-Fi is going to work. Slow. It's sort of fun, so I'm going to hopefully get it to go, but I haven't. Yeah, it's struggling here. Well, I'm going to tell you what you might see. So when you log in, say you log into your bank, you know, using a device like this, we are keeping track of the motion of the device. We're keeping track of your keystrokes. If you maximize or minimize, we're watching all that. And then eventually you hit login. And when you hit login, we process that information and decide, is it human or not? And if it's human, then you're good to go. And if it's not, then we're likely to not allow you access. We'll just say account invalid. Let's see if I can get this thing to go. Oh. I'm going to try to type in the thing here and see if it works. So there's a little number here that's going to hopefully allow them to be tethered. Ah, okay, there's working. Okay, so you see here, all right, I'll set it down. All right, I'll rotate it on the table. It's keeping track of everything there. All right, and so we're doing this under the covers for you today, for a lot of the sites you go to. And now I'm going to type in my username, and so it'll record that, Tom, and type in my password, Tom. Not a very good password. But you see, it records when I press the keys and all that. And it, you know, when I hit it, it actually moved it a little, so you get that. And now I hit login. All right, and so now I'll show you the record of, oh, I forgot to maximize and minimize. So you see that's empty here. That's me. I didn't maximize and minimize. The bots know we're doing this, so they try to create things that, you know, look human. Let's see here, the key press pattern. There you see me, Tom, and Tom there. And then you see the bots, what they might do to try to make it, you know, initially they just were up, 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 up. Then they figured out we were catching that, so they try to be more clever. But using this information, we can decide, hey, it's a human. Now, the bad guys have figured, the really good bad guys, the good ones, well, the ones that are good at being bad, have, you know, figured this out, so they started recording human profiles and using that. So then we had to say, wow, this human profile is showing up an awful lot. So now we have to keep track of that. And now what's happening is the bad guys are actually hiring humans in third world countries to do the logins. All right, so now there's a couple of things we're doing to fight that. One of them is we're actually capable now of telling the difference between me and you. Now, it's not good enough, we're not good enough to say that I do this login and without knowing my name, they can tell it's me. But because I am giving them my name and account, and they've seen me before, they have a profile for how I do it stored with my account. So when that poor person in that country far away is logging in as me, they don't have that. And we can tell, doesn't look like Tom, doing this, the profile we've had for Tom here. And also we're keeping track now of what devices you use to log into these accounts, where you tend to do it from, and other kinds of information to stay ahead of the bad guys. And this is such an industry that makes so much money that you just got to keep raising your game. Yeah?
So does that mean sometimes when I'm pretty sure I remember my password and I type it in and it just says I'm wrong, that maybe I just spun my phone around in a weird way that I've never done before?
Yeah, that's not impossible. Yeah, that could be. And of course, sometimes, what folks will do is give you a CAPTCHA test if you fail this. The problem with CAPTCHA tests is the bots are better at it than humans. So that's not so good. Yeah, yep. So very cool technology. It is a constant battle, and a lot of machine learning, as you can imagine, goes into doing this. And of course, it all has to happen, instantly. And this stuff really works. And this is the rewarding part, of what we're doing, because we can have an impact. We can make things better. This is one of probably the biggest banks in the world, and they were losing 8,000 bank accounts a month to these hacker bots. And they turned on this bot manager and this particular capability, and overnight it went down to losing one or two. Not 1 or 2,000, but 1 or 2. And just a huge benefit, stopped account fraud. And that's been now for over a year that's the case. Yeah?
So I was wondering, can I use the vocabulary to simulate a human but animal?
To have a computer to simulate a human, yeah, they're trying to do that. In fact, this is like sort of the reverse of the Turing test, where can a human tell the difference between talking to a human and talking to a computer? We need a computer to tell the difference between a computer logging in and a human logging in. And that's what we're working on, yeah.
So compromises are still most likely occurring, but you're just able to identify that it's a computer doing the login with the password and then email them to change it.
Yeah, we email to change it and we don't let them in. This has created other issues. Because for the banks, because we report all the different types of bots, they found a lot of their customers had hired a third party to manage their accounts. And the third party was using bots to access the account. And the third party was legitimate because the user had given over rights to the account management, but was not secure. All right, and the banks need to be secure, and here's this third party in the middle that's not secure. And this creates a legal challenge. Now, in Europe now, they passed laws saying banks have to respect the third parties and give them access. In this country, no, the banks are actually denying access to the third parties that don't pass security tests. But it's just a whole set of complications going into now. Who has access to your account? What can they do with it? Do they have to be human or not? There's more examples. I never would have thought about this until we see it happening, but there's big sporting events that the scalpers buy all the tickets to. There's plays on Broadway, Hamilton. All the tickets were being bought by scalpers who have bot armies. You can actually download, bot software and a bot army to, buy up the tickets for, certain big ticket agencies online. Just specialized software you buy, a few $1,000 and you can go. Sneakers. And fancy sneaker comes out. Who knew? This is a big business. And the bots go buy up all the fancy sneakers and resell them on the gray market. It's not necessarily illegal, but it's certainly not what, the apparel maker wants to happen or the ticket agency wants to happen. And we can stop this. And, just the volumes of these bots is enormous. 99.9% of the acquisition attempts are a bot trying to buy the merchandise. Airlines, especially in Asia, the vast majority of the efforts to buy a seat are bots hired by a competing airline. And so what they do is they reserve and buy out the inventory so that, or hold it so that then somebody else coming has to go to their airline. And this is standard practice in a lot of Asia. Here not so much, and the worst part for the airline is if you just go look at a price. So somebody's price scraping, looking at a price, it's an enormous cost because just to give you a price quote, they've got to go to the reservation system, and it costs them like $1 or $2. Huge money at scale for that. So the vast majority of an airline's cost is the reservation system. And so they were going underwater because of all the price scraping from the competition and the competition reserving seats. So you got to stop that. Yeah.
The bot manager can see which keys we are pressing. The key presses, they can also see which keys we are pressing. So in the wrong hands, this could be quite dangerous, right?
Yeah, we are very careful what we use data for, because you're right, we see everything. And we don't use it for advertising. We do not sell it. We don't use it for anything other than security. And that's considered, even in Europe, is considered okay to do. Now, in Europe, we can't export data with the general data privacy, GDPR regulations. And in Germany, we can't, even IP addresses are considered sensitive private information in Germany, never mind your name. Now, of course, we all know what the German IP space is, but you're not allowed to send an IP address out. So there's a lot of stuff we got to do to respect the laws in various countries. But from our purposes, we're religious about the data is owned by the website and the user, and not us. So we don't monetize that. But you're right, in the wrong hands, it's a problem. As you've seen with, some companies, Facebook and Google, what's happened there. Yeah.
There have been attempts to break your secrets.
Oh, constantly.
And did it succeed there?
No. No. Now, we have had marketing, some of our marketing machines, which aren't part of our deployed network. Sometimes they, haven't had the security they should have. But our deployed network, no, never been.
By putting false information out so that they waste time?
We do all sorts of things to protect ourselves, understand who's attacking us. We are ground zero for the internet because, all the banks, major governments, all the commerce sites, run through us and we protect them. So we're constantly under attack. We invest huge resources to defending ourselves so we can defend our customers and keeping the keys secure. It's a huge battle.
So presumably these bots that are buying out the inventory are not really buying it out. For the customers be happy. They sold all their inventory at list price instantly.
You'd think that, but no. Because they're going to sell it anyway, and they want to sell it to their real users. They don't want it to show up in the black market at 2x the price later. In fact, there was one of the shows of a big Broadway play. All the bots got the tickets. They canceled them all, and then put it back online, through us, so they could sell to real humans.
But that's because they were selling them way below market. Was the problem, right? With Hamilton and such, right?
Yes.
So if you're not doing that, right? If it's actually worth a lot more.
Correct. So we could have a good philosophical debate on, because maybe the scalpers are providing a good function. In a capitalistic society, the ticket is worth more. And that's what they do, but the ticket seller doesn't want that to happen. They don't like that. No, but it's a great point. Yeah.
We hear all these practically religious advice about how to deal with passwords.
Yeah.
Do you have any religious advice or any comment on the general religion?
No, it's hard. Everybody is vulnerable. It's just really hard. You should use a different password and make it really complicated on every site you go to, and you shouldn't write it down anywhere. That's hopeless. There's services you can buy that do this for you. Well, then are they vulnerable? And you look at Equifax, you look at other things that have happened, and you lose it there. It's and at this point, everything about you has been stolen. Everything. You have OPM, all the clearance information. Anybody who has a clearance in this country taken. You got the IRS hack. My tax forms were stolen. And I think there were tens of millions of people had their whole financial history. You got Athena. No, what was the There was a health company, 80 million health records, total health history gone. You got Marriott now, your passport data, every hotel you ever stayed in, when you were there, who else was there at the same time? Now you put that together, I'm too much of a conspiracy theorist, but you can imagine a foreign nation having all this data. The clearance, person with the spy, who are they meeting with in the hotel, blackmailing information, your emails all taken. Oh my God. You know, it's not a good thing going on out there. This is a great one. We've now got multiple companies where we have discovered the HVAC system, the air conditioning system, had been taken over because it has no security and being used to collect all the private data in the company and then exfiltrate it to a botnet. All right, in the air conditioning system. Now, you can imagine the security officer doesn't even know the damn thing's connected. All right, but somebody in the company wanted to control the temperature through the internet, through the internal network. So they connected it. It's got a full communication stack, CPU, very well connected. And so that's where the virus goes and lives. And of course, the virus comes in really easily because there's the current method for protecting enterprises just doesn't work. You got a firewall, and if you're inside, you're considered okay, but this device went somewhere it shouldn't, or it even went to an okay site where malware got, added on through an ad. Even if you go to a reputable site, most of the content there, a lot of the content comes from some third-party site they don't even know, some ad or something. Malware comes on board, you take it in to the enterprise, you come through the VPN, malware jumps off. It takes only hours to spread in the enterprise, takes months to find, way too late. Marriott, years before they discovered it. And they're not stupid guys. In fact, this is a true story. It was earlier. The morning of the Marriott announcement, the breach, I was at a symposium in Washington where they were giving out CIO of the Year awards. And there's about 10 of them, and then there's the best. The best CIO in North America was the CIO at Marriott. And I'm thinking, how is he going to be here to get this award when, this just hit the fan? And sure enough, they get to give his award. They say, due to unforeseen circumstances, he won't be here to accept his award. So clearly a smart guy. But what can you do? It's just, all right. So this is an area we're doing a ton of investment and research to try to, our next goal is to stop data breaches. We can stop denial of service attacks. You don't read about big ones against big enterprises so much now. We can stop people from corrupting websites and stealing your information from website. Next for us is stopping data breaches, which we're just starting to get the products in the market to do that. But big challenge. I'm going to say a few more words about areas that we're working on. Very buzzy, but we're putting investment into. First is Internet of Things. You all, I'm sure, know all about this, but you got billions of people, tens of billions of devices, huge amounts of information, and it's all connected. And people want to get instantaneous, intelligent access and control. And that's hard. Huge potential, just it's everything getting connected. You got problems with scale, performance, making it be real time, security, enormous challenge, cost at this scale. And this is an area where the same platform we built for content delivery can help. And so we have now an IoT platform. And the main features are that it speaks the IoT device protocols. It gives you container support for your logic at the edge server close to the end user, which is good. It's bidirectional. And the next thing we want to add here is a security layer with the goal that your devices in the home go through it and we can help keep them from getting infected, or if they do, to quarantine them and let you know. Interesting challenge. Early use cases, oddly enough, is in automotive. That's probably the best use case we've seen so far because cars are all getting connected. And a typical new car has about 70 functions it reports on in real time. And real time gets more important as you have self-driving cars. And they want to be able to have interaction with that in real time. And of course, gaming devices in your home. That's a big one. They want those always on, always connected. They want to be able to wake you up to play with your friend if your friend is online playing. Say a few words about blockchain. Again, big buzzword. And I'm not talking about digital currency, but really the ledger system. You know, a lot of potential. We'll see if it gets realized. I can tell you every bank in the world is interested. Every government pretty much in the world is interested today. Again, you got problems with scale and performance. Anything based on proof of work does not scale by definition, by design. Trust issues, who really controls it? You know, if a majority of the users can control it, that could be a bad thing because a lot of the users might be bots, might live in a foreign country, depending on your perspective. Cost is an issue. And here again, you know, we're using our Edge platform to build a blockchain platform that can scale, does not use proof of work. It's proof of permission or proof of authority. And so we can do transactions end to end. You swipe your credit card in the soda machine, in 2 seconds it's totally done. And here we've partnered with one of the world's largest banks, Mitsubishi Bank. They're based in Japan. They more or less control the Japanese economy. And we'll be bringing this into market in the Japanese economy in early 2020. And that'll be exciting. That could be the first use of blockchain really at scale at a country level. And of course, a lot of the countries in the world, including Japan, they very much want to go to a digital currency. And that's because so much of the market is crime. And A, crime they think is bad, but B, if it's going to happen, they want their cut in taxes. And so if it's a digital currency that they more or less control, they can get, they can monitor and get their cuts in taxes. Now, of course, the original creators of blockchain, well, the whole point was the government can't see it, in a sense. But there'll be competing forces here that over the long run. Lastly, say a few words about privacy. Everything about you is online. Some of you put it out there explicitly for the world to see, and some of you, it just got stolen. And even when you put it out there for people to see, probably you weren't thinking about what the Russians might do with it to influence an election, which I think at this point is pretty much uncontested that really happened. And some of the governments are just very sophisticated at how they use this. Now you go over to some countries. I had one person, a senior person in the government, say, well, the Americans were the first to do that, to manipulate elections. I don't know if that's true, but that's what some people think. But you can do a lot of dangerous things. Fake news, what's real? It scares the heck out of me. And especially when you look at the traditional trusted outlets, news companies that do investigative reporting, under pressure, in the financial pressure in the digital age. Can they survive? And if they don't survive in a democracy where you really rely on an intelligent and free press, you're in trouble. Yeah, everything is out there. These things, literally today, they're recording what you say. And some of it now, there's an argument of how long this is being kept in records. For example, things like Siri, they want enough to know, are you asking Siri to turn on? And then after some period of time, maybe it's not kept. But you've all seen the stories where, conversations showed up in somebody else's house. These things have video and are capable of, without your thinking about it, being turned on and recording. Actually, in my office had the greatest, latest Cisco WebEx screen that, my assistant can put a PowerPoint on the screen from across the country. I can edit it and it goes back. And discovered to my horror that accidentally, not on purpose, somebody was able to turn on my screen without me knowing it and watch what was happening in my office and what I was saying. And then, Cisco said, oh, we had a bug, still not fixed. It's scary. Big privacy challenges out there. Government regulations coming left and right now, not so much here, the federal government, maybe in California, but certainly in Europe. This is a big deal. This is an area that we're getting into. We just acquired a company called Janrain, and they are designed to keep the end user data in a safe way so that it can't be stolen from the enterprise. Users can opt in and opt out and provide that capability and to respect government regulation. There's very interesting work being done by Tim Berners-Lee now with the Solid protocol. He's got a company, a startup called Inrupt, to help companies adopt Solid. How many of you have heard of that? Many people? Oh, wow, not very well known. It's early days, and the goal is very good. The goal is for every user to control their own data. So the data about you is not sitting at Google or Facebook, but sitting in a pod that you control, and you can give authority for some third party to access some of your data and do specific computations. They don't get your data. That's the theory. The struggle, of course, and technically we'll make all that work. The problem is people are so used to just giving it all to Google or Facebook or anybody really, because you want some service they have. And you're not thinking about the implications of that. You want your directions to where you're going, you want the search to take place, but there's some serious implications that we're starting to see the implications of. Okay, so that's the end of the prepared talk, but happy to take questions.
So you mentioned there's sort of 3 companies out there doing this sort of aggregation. Yourselves, Google, and YouTube, which is Google, and
Netflix, doing big video.
Right. But they're doing something particular. They're doing video.
Yeah.
So basically almost all the web traffic is going through you guys.
Yeah, so if you're thinking about the other kinds of web traffic, yeah,
so
vast
my
majority.
question is, you seem like a nice guy, but should I be worried that Akamai has too much power? Why don't you get called to Washington regularly and get grilled like Zuckerberg and the rest of those?
I do spend time in Washington, and we work with the FCC. We talk to them. We're sort of a neutral party there, and it is important that we have very high ethical standards. Otherwise, really bad things could happen, and we'd go out of business because nobody would trust us with their data. So it's vital. Yeah.
Would there be a possibility to have some other country create Akamai equivalent?
Yeah, there are a lot of competitors, nothing really like us, and people don't think about it, but our largest competitor is a Chinese company. And they're actually, the laws in China are complicated, as you might imagine, for us, but they are our partner in China. For us to do business in China, we have to work with what turns out to be our largest competitor. Very, very unbalanced field of play.
So they know your phone, what to do.
Oh, they know us very well. Yeah, no, China's a very difficult landscape for a company delivering content. We've been kicked out of the country twice. Fortunately, never had anybody arrested, but it's complicated for us there. Yeah.
I see sort of an arm wrestling between the encapsulation of personal data and what you're asked by all these terms of service.
Yeah.
I mean, they're at opposite ends of the spectrum.
Yeah. No, everybody just gives it away, and I don't know that
You don't even
that'll
know
change.
you're giving it away.
No.
I mean, those terms of service.
Yeah.
So I'm an attorney,
Click.
and
Yeah, hopeless.
it's hopeless to read those.
Yeah.
Or, if somebody walks in and gives me a big wad of money, maybe I can do it. But
Yeah. No, it's
I
a
won't be
challenge.
bothered for myself.
Privacy is a big problem. Yeah.
You spoke about the distant future of the internet, and the way I understand how you described it was that it was almost completely decentralized
Yeah.
in terms of broadband and such. Do you think privacy is possible in that kind of scenario?
I think privacy is really, really hard. Because you've got giant economic entities today, and they live by that information. That's their business model, and monetizing that. And you see some of the ways that happen, and it's really scary. It's a challenge. I don't know what we're going to be solving. I'm a big fan of Tim and what he's trying to do. That is very good. That's a big hill to climb. Yeah.
So do you see it as more important to build the sort of technology so that people don't have to be as careful, or to sort of change people's ideas about what it means to be careful?
It's hard to change people's ideas, you know. I mean, nobody can follow the right security practices. I can't even do it. You know, the best chief security officer in the world can be hacked. That's hard. So we got to build in layers, I think, to help mitigate the problems, knowing that people aren't going to be able to do the perfect things. So you got to build that on top. Yeah. Say that again? Opportunities, you mean, areas of business? I think, you know, privacy is an important area. You know, Internet of Things, we'll see. But making all that work so you get real-time alerting, command and control for vast distributed systems, you know, sensors, you know, all over the place. I think, you know, the CDNs could have a role to play there. A lot of investment will be needed, but potentially very interesting.
Thank you very much.
Thank you.